The question is like this, that this is a conducting sphere. So in this conducting sphere you have a cavity, and say at a certain distance from the center of this conducting sphere, say you have a point. So you have a point P at a distance r from the center of the sphere. So let me color the conducting sphere, this part. Okay. So now at this point P, so at this point P, yeah. So at point P, you need to find the potential. Okay. Now, so inside this cavity, you have a charge. Say you have a point charge, say minus q. So if you have a say plus q, if you have a charge plus q inside this, then so in the inside surface of this, you have a charge minus q. Inside surface of the sphere you have a charge minus, because this got to be there, right? Because if you apply Gauss's law here, the field in this conductor is equal to 0, so the net flux, that is the net charge enclosed, is 0. So minus q, and as a whole this conducting sphere is neutral, so this charge plus q will settle on the outer surface of the conducting sphere. Now see this point, the charge q is settled on the outer surface of the conducting sphere, while no electric field crosses here. Here at all points this electric field is 0. So it's like that the charge, so if I draw this again, sphere, that is certainly this charge q lands up on the outer surface of the sphere, and they have got no knowledge what is happening inside the sphere. Now why I am telling that they have no knowledge what is happening inside the sphere? Because inside the sphere, at every point inside the sphere, the electric field is 0. So as the electric field is 0, so whatever is happening inside the cavity or inside any say inside this cavity, it cannot communicate. This means that, see, charge will communicate through fields, right? So the electric field is 0. So actually, in speaking in Professor Walter Lewin's language, this charge q doesn't know what's going on inside, right? So that means the charge q will be uniformly distributed on the surface of the sphere. The charge q will behave as if nothing has happened inside the cavity. It has got no knowledge of what has happened inside the cavity. Now you see there is a charge sphere, that means charge is outside, and you have a point P here. What will be potential? So obviously potential is 1 by 4 pi epsilon naught q by r. Similarly, there was a question that you have a sort of cavity, or say a conducting sphere, then you have a cavity inside this conducting sphere. Let's color this. Now inside the cavity you have got a dipole. Say there is a dipole, plus q minus q. See, and you know, dipole means there will be no charge absolutely inside, because if you apply Gauss's law here, inside conductor, you know, field is 0. So charge enclosed is already 0, because the dipole has plus minus charges. So net charge is 0, so no charge. So even the outside surface, no charge will reside. Now when you try to calculate potential at a point P is at a distance r from center of this sphere, then obviously here also the point P, even here in Professor Walter Lewin's language, you can think that point P doesn't even know that there is a cavity inside, because as it's a conductor, so this conductor acts like a shield. That means no electric field lines can pass through conductor. So this is a shielding effect of the conductor, and hence this point P, that means potential at point P means you bring in this point P from an infinite distance. So from infinite distance you bring in point P. So how does that matter whether there is a cavity or whether there is a dipole, it doesn't matter, because the electric field lines doesn't cross conductor due to shielding effect. This is known as shielding effect of conductor.